one is 1 over 4. How did I get 1 over 4? Yeah, I went 1 over 2 squared, and that's how I got 1 over 4. What do you do for the second one? We've already seen this one, right? Yeah, you reciprocate, and then this becomes positive, so then we get positive 4. What happens when we have a fractional exponent? Yes, and so just in case your teacher didn't stress this enough, I can't stress this enough as well. You always try to do the radical first, then you square or cube or whatever. So you should always do, for instance, in this case, the 2/3. The 3 on the bottom means a cube root of 8. Then we have to square it. So what's the cube root of 8? 2. And then 2 squared gives you 4. Next one. Again, we're going to cube root it first. So we're going to cube root 27. And then that's going to be to the power negative 4. So what's the cube root of 27? What's 3 to the power negative 4? 81 where? Top or bottom? 1 over 81. Very good. Yeah, because it's negative. It's a negative 4/3, so I stuck the negative with the 4, right? Because remember when we write a fraction, it doesn't matter where you put the negative, but it only makes sense to put it with a 4 on this question. So 5th root of 32 into that to the power 3. So 2 to the power 3 is 8. Very good. Okay, so to solve exponential equations, we write each side of the equation using the same base. Once we equate the bases, the exponents are also equal. So that means what I'm trying to say in algebra terms is if the two bases are the same, that makes these two exponents equal. Okay? So, and of course, this only works if you have the same base. So in the first question, I don't know, maybe you've seen something like this before. If you have 4 to the power x, how could I figure out what x is? No. No. No, it's not a 4th rooted. No. Okay, so maybe you haven't seen this before. So what you have to do is you need to write in terms of the same base. So for instance, 64 is 4 to the power what? 4 to the power 3? Does everybody agree? So that means if these two bases are now the same, that means x equals 3. Okay, so why is it working? It's a theorem that we just went over. So what is 4 to the power 3? 4 times 4 is 16 times 4 is 64. It works. If the bases are the same, then the exponents are equal. So another way to do this, and this is the way I highly recommend, is instead of trying to get one in terms of the other, change them all to prime number bases. So for instance, in the first question, 4 is 2 to the power 2 to the power x. Does everybody see that? I'll show you in a second because you wouldn't be able to solve it coming up otherwise. 64 is, well, we already saw that 32 was 2 to the power 5, so 64 would be 2 to the power 6. Remember your exponent laws, if you have a power to the power, that means this is 2 to the power 2x equals 2 to the power 6. Again, if the bases are the same, that means the exponents are equal, which means 2x equals 6. And divide by 2, I get x equals 3. Either way, we get x equals 3. So the reason I showed it to you that way is the next one coming up. If you only see one way and you try to think you're going to change this to 4s, it won't work. If you change it to 2s, that's why I say in all of these, when you start doing your homework, change it to prime number bases. So 4 is 2 to the power 2. 8 is 2 to the power 3. And of course, 8 was to the power x. Does everybody see what I did? Then I need to have a power to the power rule. So that means I multiply. So I get 2 to the power 2 equals 2 to the power 3x. If the bases are the same, the exponents are equal. So 2 equals 3x. So what does x equal? How about 2 over 3? Okay, let's go on to the next one. 3 is already a prime number, so we'll leave it the same. 3 to the power 4x plus 1. What's 27? 3 to the power 3. And then again, that's to the power 2x. What's the exponent law we're applying right here? We're going to multiply those. So if you already see that our bases are the same, can I skip the step where I rewrite it multiplied and just go directly to 4x plus 1 equals 6x? Is everybody good with what I did? Okay, good. So I'm going to move the 4x over. I get 1 equals 2x, so x equals 1/2. You see that? Sure. Okay, let's move on to D. 3 to the power x times, what's 27? 3 to the power 3, it's 81. 3 to the power 4, and that's to the power 2x plus 1. When you're multiplying the same base, what do you do to the exponents? You add them. Very good. So I'm going to show my intermediate step at this point. So 3 to the power x plus 3 equals, of course, power to the power. What do we do to those exponents? We multiply. So 3 to the power 8x plus 4. Again, you could skip this step, but now my bases are equal, which means my exponents are now equal. So x plus 3 equals 8x plus 4. Yes? We're going to move, it doesn't really matter. I'm going to move the 8x over, so I get negative 7x equals positive 1. So what does x equal? Negative 1/7. Yeah, so it takes practice. It takes practice for sure. Okay, again, prime number bases. 4 is 2 to the power 2 to the power x plus 1 is 2 to the power x. Who knows what the square root of 2 is written as an exponent? 2 to the power 1/2. Very good. 1/2. Remember, back up at the top of the lesson, the 3 on the bottom meant 1/3. That's the cube root. So square root is a 2 for the radical outside, like we had the 3 for the cube root. We just don't write the 2. And so that's the half. So again, we need to multiply that. So we get 2x plus 2 equals, what do we do here when we're multiplying the same base? We add them, so then we get x plus 1/2. So let's move the x's over to one side. So x equals, I'm going to move the 2 over to the other side. So what's 1/2 minus 2? Negative 1/2. So what's that as a fraction? Negative 3/2. Very good. Okay, moving on. This is the biggest mistake people make. They think that they can do whatever they want and they don't follow BEDMAS. They think that this is equal to 6 to the power x. It is not. Please don't make that mistake. Don't multiply before you apply the exponent, right? If a number is attached to an exponent, you can't do anything with it except maybe some exponent laws, okay? Does anybody know what the negative 8 to the power 5/3 is? Okay, we can, yeah, since you could do that if you wanted, or you can write it as a 2. So what do you want to do? Do you want to actually evaluate it? So what's the cube root of negative 8? Negative 2. What's negative 2 to the power 5? Negative 32 equals 2 times, now this is going to be, I'm just going to write it as 4 to the power 1/2 x. Is everybody good with that? And x over 2 is the same thing as 1/2 x. So now this is a negative 32. So can I write that as negative 2 to the power 5? Yes? Okay, now this is 2 to the power 1. Yes? Times 2 to the power 2 to the power 1/2 x. When you multiply 2 times 1/2 x, what do I get? Yeah, you just get x. The 2's will cancel and you're just left with x. So what does the right side become? 2 to the power Yes, 1 plus x. Now, if you get down to this step and you have a negative equal to a positive, is that possible? No. So what would we write? No solution. Even if we switch the negative over to the other side, it would still be, this would be negative, this would be positive. Okay, let's try the next one here. So if you try to write this in terms of prime numbers, you might get stuck. The first thing you need to realize is, although you can't go 2 times and get 6 to the power x, like I said, note up there, you can get rid of this 2. The 2 is not attached to an exponent, so you could technically divide by 2 to both sides. Does everybody see that you could do that? So what is that equal to on the other side then? 81. And I bet you can see that 81 is 3 to the power 4. Now, although the 3 is a base 3, it's not really a base 3. It's essentially 1/3, right? So how can I make this 3 on the left side? Very good. Yeah, negative x plus 1. No, you don't need brackets. Yeah. Okay, so does everybody see what I did there? I raised the 3 to the top, and then I switched the signs of the exponents to compensate, right? So that means negative x plus 1 equals 4. Negative x equals 3, so x equals negative 3. We good? Okay. How would I solve this? Well, we just need to do power to the power. So what's 2 times 3 over 2? 3. So we get x equals 3 to the power 3. Does everybody see? 2 times 3 over 2. The 2's cancel, and I'm left with a 3 for the exponent. So what's my x answer? 27. How would I solve this one? What did I suggest doing first? You square root first, then you cube, right? So square root 16 is 4. 4 to the power 3 is 64. Very good. Okay, this might be something you haven't seen before. How would I get x to the power 2/3 into x to the power 1? What would I have to do to both sides to get an exponent of 1? How do I make 2/3? What would I have to do to that to get 1? Divide by 2/3. What's the same thing as dividing by 2/3? Multiplying by 3 over 2. So if I do a power of 3 over 2 to both sides, does everybody see that I will get an exponent of 1 there? So then what is 4 to the power 3/2? 4 to the power 3/2. 8. Very good. You square root 4, you get 2. 2 to the power 3 is 8. Okay, how about this one? How would I get x to the power 1 there? It's not actually a multiply. What I'm doing is doing a power of 3 over 4 to both sides. But in fact, what I'm doing is multiplying the exponents, right, to get 1. Okay, so, you might not know what the 4th root of 625 is. It is 5. Very good. So then it's 5 to the power 3, which is 125. And we're done.